So hello everybody. Today this one is example. I'm solving example here for the mechanics subject. Okay, so till now we did completed two lectures. So now in the third lecture or the third part we are going to solve some problems. Okay, so let's see what the first example says. Okay, so the first example here says three forces P, 2P and 3P. Okay, so there are three forces and they are written that they are exerted along three sides of an equilateral triangle. Okay, so first we will make an equilateral triangle like this. Okay, so let's suppose 3P is here, P is here and 2P is acting here like this. Okay, 2P. So remember the direction, this would be like this. Okay, or you can make it in the opposite direction. Okay, and in clockwise direction as well. Okay, so and start up an equilateral triangle. Equilateral triangle means all the angle they are making is 60 degree. Okay, 60 degree, that is 60 degree. As shown in the following figure, determine the resultant forces. Okay, so we have to find the resultant forces from the these. Okay, so what we need to do is see, first we will calculate the all the forces in x direction. Okay, summation of all the forces in x direction. Okay, so this force is pointing in x direction only, right? This one is horizontal forces and other two are not in the horizontal forces. That's why we have to resolve these forces in x and y direction. Okay, so let's suppose this one is y direction, this one is x direction. Okay, so this one is this angle is 60, that means this plus this would be 60, and then other thing is that this is a equilateral triangle, that's why this one is also 60, this one is also 60. Okay, so now we will resolve the forces. So let's suppose we will take this direction as a positive, so P would be P. Okay, and this force 2P would be like something this 2P, and 3P is in this direction. Okay, 3P. So that means I will change the color so that will make it easier for you. 3P is in this direction. Okay, and 2P is in this direction, means both forces are in the negative x. So we will write a 2P, this one is cos 60 minus 3P cos 60. Okay, so how much it is? It will become P minus 2P into cos 60 is equal to 1 by 2 minus 3P into cos 60 is 1 by 2. Okay, so 2 2. Okay, so this means cancel. Okay, so it will remain 3 by 2P, that means minus 1.5P. Okay, now we will do the same thing in by direction. Okay, so we will add all the forces in by direction. So this is the horizontal forces, that means it having no component in by direction. Okay, in the vertical direction, since the force is acting in the horizontal, so that's why it will become 0. And see, this will the upward side we will take as a positive. I have written here y, so the 2P will be positive term, so 2P sine 60 minus 3P will be a negative term. Okay, so 3P sine 60. Okay, so how much it is? 2P into root 3 by 2 minus 3P into root 3 by 2. Okay, so it will become I guess equal to minus 3 root by 2. Okay, so 3 minus 3 plus 2 is equal to minus 1. Okay, and minus 1 multiplied by minus 3 root under minus 3 by 2. So the net forces we can calculate it as a resultant forces would be Fx and Fy. Okay, so this is pretty simple question, not anything to do with 3 by 2 ka whole square and then P square and then plus minus root 3 by 2 ka whole square and then P square. Okay, so we will take out the P outside, and we will 9 by 14 4 and 3 by 4. So how much it will be? P into 3 12 4, that is 3. So the answer would be root under 3P, 3 multiplied by P. Okay, so this is the resultant force that that they are asking it. Okay, so I hope this question get it true. This one is pretty simple question, that's why I'm going to solve all the questions quickly. Okay, I'm not wasting any time here. Okay, so the resultant of two forces, two concurrent forces means they are acting at the same point. Okay, so let's suppose 3P 3P, and another force is 2P. Okay, Okay, so 2p. Okay, is r. Okay, so we will make a resultant force here, that is r. Okay, if the first force is double, first force is 3p. So if we make it double, let's suppose this point, and I will make it 6p, and here it will remain 2p. So now if we changes it to double, then the resultant would become 2p. Okay, so double. So determine the angle between the forces. Okay, so there would be some angle in between of the forces, let's suppose theta and theta. So now we have to find the angle between them. Okay, so first we will find the r. So sorry, this one is there. So using the formula from the triangles are 3p square, I mean 9, plus 2 cos 2p whole square, and plus 2 into 3p into 2p into cos theta. Okay, theta is the angle in between them. Now if for this case we will write 2r equal to 3p ka whole square, okay, plus 2p ka whole square plus 2 into 6p. Now the portion is to 6p into 2p into cos theta. Okay, so I'm just following the formulas, and we will equate both of them. Okay, so if we multiply 2 in both LHS and both RHS, these two equation can be equated as a 1. Okay, so now we can write it 2 square into, we will squaring it both side by equating both of them. So 9p square and plus 4p square plus 3 to the 6 to the 12p square into cos theta equal to I mean 6 30p square, 36p square plus 2 to 4p square. Okay, plus 6 to the 12 to the 24p cos theta. Okay, so if you solve all of them, you will get 1 plus 2 cos theta equal to 0. Okay, that means cos theta equal to minus 1 by 2. That means theta is equal to 120 degree. Okay, so this is the answer for the second question. So I hope this question is clear to you. This one is also a very easy question. I will gradually increase the toughness of the questions here. Okay, so now we are moving to the question number 3. Okay, so what the question number 3 says, let's suppose a weighted is supported by 2 cables. Okay, so I forgot to draw the picture here, so I will draw it here quickly. Okay, so these two are the balls. Okay, and one is coming, this would be a straight line. Okay, one is coming like this and another one is like this. Okay, so yeah, okay, now the W force is separated by 2 cables, this one T1 and this is T2. Okay, and this angle is 60 degree and this one is theta degree. Okay, now we have to find the value of tension, find the value of theta, the tension in the cable making be minimum. Okay, so we have to solve the value of theta. Okay, for which the tension in the cable should be minimum. That means the T1 should be minimum. Okay, so simply we will resolve the forces here. Okay, so if we resolve the forces in x direction, it will be simply written as T1 cos theta, okay, equal to T2 cos 60 degree. Okay, because W is acting on the vertical direction only, so it would come in bi-direction. Okay, so W is equal to T1 sin theta plus T2 sin 60 degree. Okay, now we have to replace T2 with T1. Okay, so T2 is equal to T1 cos theta degree divided by cos 60 degree. Okay, cos 60 degree is 1 by 2. That means it will become 2T1 cos theta degree. If we put these values in this equation, what we will get, W equal to T1 sin theta, okay, plus T2 we will replace T2 with the value that we got here. Okay, so it will become 2t1 cos theta into sine 60. Okay, so if we put the value of sine 60, it would be root 3 by 2, and 2 will cancel. Okay, that's why we can write it w equal to t1 sine theta plus t1 cos theta into root 3. Okay, now we have to find a value of theta such that t1 should be minimum. Okay, so we will equate it like t1 dt1 divided by d theta equal to should be 0. Okay, so that t1 will be minimum. Okay, this is the older concept that we have studied in our school days. I mean, in the higher classes like 11 12th, we have studied that for minimum value the differentiation should be equal to 0. Okay, so I'm not going to explain that much in detail here. So our aim is to solve the question. Okay, so I will differentiate a whole part. So since w is independent of theta, so it will become 0, and dt1 by d theta into sine theta. Okay, plus if we now differentiate sine theta, so it will become cos theta, and another we will write root 3 as a constant, and d theta 1 by d theta multiplied by cos theta, and second time we will multiply differentiate the cos theta, so it will become minus sine theta. Okay, differentiation of cos theta is minus sine theta. Okay, and if we solve the equation, we will get t1 cos theta equal to root 3 t1 sine theta. Okay, so t1 get cancelled, so we will get tan theta equal to 1 by root 3. Okay, so the value of theta is equal to 30 degree. Okay, so I hope this question is also clear to you. This one is also a simple question. Okay, gradually we are increasing the toughness of the question. Okay, I'm increasing the toughness of the question. So question number 4 is saying an electric fixture weighing 80 Newton hangs from a point C by two string AC and something. So I will draw the figure here first, then you will able to understand that. Okay, so this one is wall, vertical wall. Okay, this one is horizontal wall. Okay, and A. Okay, this one is B. Okay, now one wire is coming like this. Sorry, this should be straight line. So okay, and from here one line is coming. Okay, 80 Newton is here. Okay, this one is having T1, this one is having T2. So angle here it is 50 degree, and the angle here it is 40 degree, and the angle here is as well 40 degree. Okay, this point is C. Okay, this extended line having a point D here, and everything is okay, right? Okay, so now we will read the question. An electric fixture weighing 18 Newton. Okay, this one is 18 Newton from a point C by two strings. From point C, the two string is getting connected here, AC and BC is shown in the figure. The string AC is inclined to the vertical wall at 40 degrees. 40 degree. This means this one. BC is inclined to the horizontal ceiling at 50 degree. I mean this one. Determine the forces in the string. So we will have to find T1, T2. Okay, T1 and T2. Okay. Now this one is 40 degree, right? So from the geometry, these two lines are parallel, right? This line and these two line are parallel. That's why this angle is 40 degree. So this will also become 40 degree. Okay. And now from the straight line equation, we will find this angle as 180 degree minus 40 degree, right? Similarly in this case as well. So now the figure will become simply like either 80 Newton. Okay, and here T2 is acting, right? T2 is acting here, T1 is acting. Okay, and now I will write the angle here. Angle here it is 80 degree. Okay, and here it is 180 minus 40 equal to 140 degree. 140 degree. Similarly in this case as well, this is 140 degree. Now we will use the sine law for this concurrent forces. Okay, the sine law says that T1 divided by sine of angle opposite to this t1, that means this one 140, okay, 140 degree, okay, and t2 opposite is 140 degree as well. We will add t2 divided by sine 140 degree. Now the opposite angle of 80 Newton is 80 degree, okay, so we will write t3, sorry, this we know, so that's why it would be 80 Newton and sine 80 degree. So we will find t1 as 80 Newton sine 140 Newton divided by sine 80 Newton, okay, so sine 80 degree, so this will become 11.75 Newton, okay, so this will be equal to t2 as well, okay, because sine 140 degree will be getting multiplied here in this case as well, okay, so this one is your answer, okay. So I hope this question is also clear to you, and this one is also a pretty simple question. Now we will come to question number 5, okay. So question number 5, determine the resultant of the coplanar concurrent forces shown in the following figure. So I forgot to draw the figure, so I will draw here. Okay, so I mean, let me draw the, okay, okay, and I will make a copy of it, okay, and I will paste here. Am I not able to paste it? Okay, and I will rotate it like this, and I will make it here, okay. Okay, so now sorry, so here the force is acting is 100 Newton, here the force is acting is 150 Newton, okay, here the force is 250 Newton, here the force is 200 Newton, okay. Okay, now I will add the angle. So angle here is 30 degree, okay, and here it is 20 degree, and here it is 70 degree, okay, and here it is 45 degree, and this is this one is 0, okay. Oh, sorry, so we have to find the resultant forces, so that's it. I mean, waste of time. It's a very simple question, that is we have to calculate fx, so it would become 150 into cos 30 degree, sorry, it would be negative, so in direction we are taking negative, sorry, negative, in this direction we are taking positive, that means this one is positive x, this one is positive y, okay. So this, that's why we have taken the component of this will lie in this direction, that's why I have taken negative sign. So minus 150 cos 30 degree, so and for 100 Newton it would be positive, so 100 into cos 20 degree, okay, plus 250 into cos 45 degree is here as well, and minus 200 Newton into cos 70 degree as well. So you will just put the values and you will get the answer as 72.44 Newton. Similarly in Fy, I'm not going to write it here, I will just directly write the answer which I am getting after calculating it, 255 Newton, okay. So again the resultant forces would be fx square plus fy square, okay. We will square both the values and then make it under root, and we get the answer as 265 Newton, okay. Now for finding the angle, that is overall we are getting some resultant forces, okay, like this one is x, this one is y, and we will get something resultant forces, so we have to find the alpha bit horizontal, the angle of resultant forces making with the horizontal angle, okay. So tan alpha will become fy upon fx, okay. So alpha would be equal to tan of inverse fy upon fx, okay. So tan inverse fy means 255, sorry, 255, okay, and that one is 72.44, okay. I mean negative, here it is negative, so the angle will be changed, okay. If you put the negative and a positive sign, the angle would be changed, the answer would be 74 degree. So I hope this question is clear to you. I mean nothing to do here, this the calculation part is there only, okay. in this question, particularly in this question. Now we will move to question number 6 and 7. So for both questions 6 and 7, we are having the same picture. Okay, so I am going to draw the figure here. One second, this one is not horizontal line, so I will try to make it horizontal. Okay, this one is perfectly fine. Okay, and okay, and vertical body is attached 600 Newton. Okay, this one is making 30 degree. Okay, this one is 60 degree, and here as well this one is 30 degree and here is 60 degree. Okay, these all are given in the question. This is the figure. Now I have to write the pointing. This one is PQR. Okay, so again this is the similar question as this. Okay, that we have did here. Okay, so we will do the same thing. So this one is also a pretty simple question. Now we will do it. So tension in the wire QR. We have to find the QR, and here it will be PR. Okay, so just simply we will write here. This one is okay. This one is 600 Newton. This one is let's suppose I'm calling it as a T1 and this is T2. Okay, so now this angle is 60 plus 30 is 90 degree. Okay, this angle is 90 degree, and if we subtract 180 minus 90 we will get 90 degree. Here 180 minus 60 we will get 120. 180 minus 30 we will get 150 degree. Okay, so this angle is 150, this one is 120. Okay, so now we will again use the sine law, and we will get 600 Newton divided by sine 90. Okay, equal to T2 divided by sine 150. Sorry, the opposite of this is 150. Okay, and the opposite of T1 is 120 degree. Okay, so remember that, don't make any mistake. Okay, sine 120 degree, and we will get let's suppose T1 is equal to 600 into sine divided by sine 90 is 1. Sine 120 is 90 plus 30, so cos 30 is root 3 by 2. Okay, so it would become root 3 by 2. 300 by 300 into root 3, that would become 519.6 Newton. So the answer would be A. Similarly, we will find T2 as 600 into sine 150. Okay, so it would become 300 Newton. So option B. So I hope this question is also clear to you. I am solving it quickly. So 3 more questions are there, so I am solving it here quickly. Okay, this one is pretty simple question. A point is located at minus 6 to 16 with respect to the origin. Okay, so okay, let's say this one is X, this one is Y, and this one is Z. Okay, so here it's saying a point is located at minus 6. Okay, that means minus 6 means somewhere here. Okay, so this one is minus 6. Okay, and then 2, that means we have to climb 2 in positive by direction. Okay, so this one. Okay, we have first gone there, then here, and then in Z direction how much it is? It is saying 16. So from here we will move in here at 16. Okay, and the final position would look something like this. Okay, so this is our the required vector, that is the point located 0. This one is 0 0 0, and this point is minus 6 2 and 16. Okay, so now what they are asking, specify its position in terms of orthogonal components. Okay, so in terms of orthogonal components means we have to write the vector R as simply we can write it 6 minus 6i plus 2j and plus 16k. Okay, so this one is easy, we can write it done. So first question is done. Okay, now second is in term of direction cosines. Okay, so direction cosines means what? L we will find the A layer. Okay, I mean you know this, right? Cos theta x, that means minus 6 the x component divided by 6 square plus 2 square plus 16 square. Okay, the magnitude of this vector. Okay, that means vector r. Okay, this is magnitude of vector r. So it will be something like magnitude of the vector is, first we have to calculate this, and it will be coming as 17.2. So this value will become minus 0.3488. okay, and m as well, this will be simply similar fashion we will write as 2 divided by magnitude of r. So it would become 0.1163, right? And then n we will write as a cos theta z. Okay, and this will be known as cos theta y. Okay, so this will become 16 divided by magnitude of vector r, and it will become 0.9302. okay, so now we can write it as the vector r in terms of cosine component, direction cosine is 17.2, okay, into L into I cap. Okay, L is the value of this. Okay, and then 17.2 m in J component plus 17.2 n component or K cap. Okay, so this is the square direction cosine component, and for unit vector component we will write simply as a r as a minus 6 divided by vector magnitude of vector r I plus 2 magnitude of vector r and j plus 16 divided by magnitude of vector r plus k. Okay, so this is the simple ways we can write. Okay, so again question number 6 is done, 8 is done, and we will move to question number 9. Okay, so again I'm going to solve this as quickly as possible. Okay, so this one is okay. So one triangle is there and having two support. Okay, so some force is acting at P. Okay, and some angle is there 45 degree, and here it is 30 degree. Okay, so this point is A, this is B and C. Okay, so now what's the question it's asking? A tension in the member CB. Okay, so we have to find a tension in the CB. Okay, so we will draw the forces here. So see, we can draw it like this. Okay, and tension here is TAB, and here as well, and here as well TAC. Okay, and here it would be tension, here it will be TBC. Okay, so now we will make the since point A is not moving, right? That means what? It is in equilibrium. Okay, so we will solve the equilibrium at point A. Okay, so first we will write for horizontal components, that means apex, we will write as TAB. I mean, this one is 45, this one is 30. Okay, so this one is 90, so this will become 60 and this will become 45 degree. Okay, so TAB, okay, yeah, TAB means this one. Okay, cos 45 degree equal to TAC into cos 60 degree. Okay, and in vertical direction at point A only, we are getting at point A only. So P is equal to TAB sine 45 degree plus TAC sine 60 degree. Okay, and by solving these two equations we will get we will have to find TAB, right? So we will replace TAC as TAB. We have did this question earlier as well. Okay, in the same process. Cos 60 is 2, so we will write TAB into cos 45 degree. Okay, and we will replace TAC here and we will find TAB as in term of P, and we will get it as, I am directly writing here, you can solve it by yourself. The answer would be same. I have solved it. Okay, that's why I am saying. So root the 6, and this will be getting as tension in AB. So we are getting this one, we got this one, so we have to find BC. Okay, now what we need to do, we found out TAB. So now we will do the same thing but at point B. Point B. Point B is also not moving, so it is also in equilibrium. It is also in equilibrium. So we will equate in the x direction. So TAB into cos 45 degree is equal to TBC. Okay, at point here the component of x is here. Okay, and by direction this is the normal balanced by the reaction forces here at B. Okay, so we can find it out. TBC directly here. So TBC will be equal to cos 45, okay, 1/2 into 2 into root 3 divided by root 6 plus root 2 into P. Okay, so the overall value we will get is TBC is equal to 0.633 P. Okay, so the answer would be 0.633 P. Answer would be B. Okay, so I hope this question is also clear to you. We did the same question earlier also. Let me show you where I did. This question we did the same thing, right? We have calculated T1 and we have replaced here, and we get the value by differentiating here, and here we have to find the values. Okay, so no differentiation is here, so that's the only difference between this question, but the overall concept will remain same here. Okay, so this is the question number 10th. So a man sitting on a wheelchair tries to roll up a stem of 8 cm. The diameter of a wheel is 50 cm. Okay, the wheelchair together with the man weighs 15 Newton. What force he will have to apply on the periphery of the wheel? Okay, so I'm not going to solve this question because the video is enough long to upload it here on the YouTube. So I am leaving it this question for you people to solve it, and please write the comment in the comment section what's your answer is coming. If your answer is not correct, or if you're not able to solve it, please let me know. I will try to solve it as you write in the comment section. Okay, so till then, keep learning and goodbye.